In this video, I'm going to be going through some notes relating to HSC engineering studies or Year 12 engineering studies. This is Chapter 2, Transport. And what we're doing is we're picking up from, I have previously talked about the first introduction in a separate video. But what we wanted to talk about was the materials. I talked about this last lesson, but I just want to revise a couple of things. And then we will go on to, we'll just follow on from the book from there. So we talked about materials. We ran through quickly the steps in the development of bikes. So we said first bikes that could be considered bikes. It really goes all the way back to the Laufs machine, which is just something that you run against. And then there's Drace. I can't remember. I've forgotten his name. Carl von Drace, I think, was 1939. That actually, I think, is it's not Kirkpatrick, but it's something like that. Macmillan. What's that name? Anyway, I don't even care. That's how much I'm interested. I think that the first one is in is it 68 or 69? 1869, 67. And so that who was that? So French dude starts with an M. Yeah, Michaud, maybe it's something like that. And the X is silent. Michaud, he was selling them in the Paris Expo, and that was like actually in production. So I think that's a good place. First mass-produced bicycle. When we watch the video in a way, let's see how much do I want to click around. I don't really want to click around very much. Luckily, I found it very quickly. So in this video we watched last year, we see that here we have a bike that's one of these early bikes. So this would be an 1880s bike. And in the 1880s, the bike was made out of solid steel, or solid wrought iron is probably actually would have been made of. And the wheels, I think we saw before, the tires were wrought iron. I think maybe this was cast iron, the wheels were wrought iron. That makes more sense. And they have direct pedals, so no gearing. And then we compare that to a bike, we can find the video, a bike that was made in 1888, which was just after, where does this video start? At 5 minutes. In 1888, Dunlop developed a pneumatic tire. So let's have a look here. So we have these two bikes back to back. Okay, so this bike here looks pretty much, it looks much more recognizable as a modern bike. It has a chain, it has a rubber tire, it has tube steel. And the difference between this and the earlier bike, only 10 years older, is incredible. So much so that this guy will ride a bike against professional racers and he will win because his bike is just so much better. So this is the professional rider using the 1880s bike, and he's riding the 1888 bike, which has pneumatic tires. Huge difference in performance. Okay, so when we talk about bikes, that's where we want to start. So 1888 pneumatic tires, and that's where we start seeing mass production. That's where we start seeing things better. So from there we have freewheeling hubs, we have internal gearing, we have recumbent bikes, better comfort but outlawed from racing, stalled the development. So racing is a really big part. It's a social consideration. So we talked about this with brakes last year, that if you're talking about social impacts of transport, racing is a huge one, right? It drives a lot of the innovation. We then talk about aluminium as being a strong and light material. It has a high strength to weight ratio. After World War II, the widespread availability of cars, automobiles, reduced the popularity of bikes. The oil crises of the 50s and later up until the 70s did push people more back onto bikes because of the high cost of fuel. Then talk about mountain bikes, BMX, mountain bikes, recumbent bikes, and more in the 1990s we started to see things like carbon fiber as being a more mainstream material. Okay, steam. We talked about steam has existed for a long time before it was used as steam engines. It was used initially in pumps to pump out mines. Initially, mines still used rails, but ponies, or sometimes humans, would pull the carriages, so the rails just kept things on track, especially if you're in soft soils. Then we have the Puffing Billy is, I think, the first steam train, but the one we usually like to focus on is Stevenson's rocket, which was developed in 1829, which is also the first 18XX game. By 1830, trains were being used in steam trains were being started to use in America, in the East Coast. Trains were very important in World War I and World War I. Of course, that should be World War II. After World War II, we started to see coal be replaced with diesel, which we talked about how the diesel electric motor gives excellent traction, which means it's good to start the train. Electric networks are more efficient, right? They are more efficient, they're more reliable, but they do lead in less pollution because there's still some pollution. If they're electric, they still produce some pollution, unless they're made from solar. And even solar power still has some pollution associated with it. You have to make the solar cells. Right, wind power, same deal. But it's definitely less than if we're using coal. Then we have high-speed trains. We talked about the TGV, the train de grande vitesse in France, and the Shinkansen, or the bullet train in Japan. Okay, we now have a lot of electric trains and light rail that are being rolled out in major cities. Okay. In terms of materials used, where we talked about, well, initially for bicycles, the first bicycle was made out of timber. We talked about what are the benefits of timber. We said that it's cheap and easy to use. Now, we said we don't really like to write the word cheap in a HSC exam. What we should say is it's plentiful, as in there's lots of it around, and it doesn't require a whole lot of processing, right? It doesn't have a high processing cost or production cost. So that's what makes it cheap. In terms of being easy to use, we had some debates over this, but the fact is that timber, generally speaking, is a lot easier. We do Year 8 timber, well, in Year 8 timber, we do a lot more joining of materials than we do in Year 8 metal, because joining metals requires more work. Yes?
It's easy to automate with metals, like robots.
That's a great point. Okay, it's a really good point. It is easier to automate production with metals. I'll give you that. But timber, it really thrived at a time when more and more things were done by. As we go back in time, we find that there was less mass production, and therefore timber was a more viable material. Okay, so iron was used as the frame on the wheels. So iron has properties that do make it appealing for early wheels, in that compared to wood, timber wheel, a wooden wagon wheel is going to wear away much faster than one that has timber on the outside, metal on the outside. There's the big advantage though of our modern tires, of using pneumatic tires, is just drastically improved comfort. Right, we get much better comfort. We also have better traction. It grips the road better. Okay, so eventually steel was produced by, so steel has been used since the Roman times, but generally when we talk about modern steel, we talk about the steel that's resulted from the Bessemer process. The Bessemer process happened right at the same time that trains and bikes were starting to be produced, which was 1856. Eventually we got to tube steel, which drastically reduced the weight. Because tube steel could be so strong, it drastically reduced the weight of the bicycles. Eventually we started to use alloys like the Reynolds 351. So it's a manganese molybdenum alloy, and then eventually we have chromium molybdenum, also known as chromo. There are some issues, right? So we talked a little bit yesterday about initially the more expensive bikes were brazed and cheaper ones were welded. And there would be lugs, so a part that went around that held pieces in place. As MIG and TIG became more affordable and higher quality, welding wasn't seen as being a downside, and that's where these materials started to become more appealing. The big advantage of the Reynolds, so we have Reynolds, they have like the 361, for example, and the True Steel OSX, is that when you weld, they're strong after welding. Right? That's what I said I wanted you to remember. If I talk about Reynolds steel, what's the advantage? is that they offer some varieties that are strong after welding. We talked about stainless steel, and the big advantage of stainless steel is that stainless steel can have very, very high strength. Also, they have good corrosion resistance. Aluminium has good corrosion resistance. We're going to talk more about aluminium later, but aluminium really started to become more popular as TIG and MIG welding became more readily available. Titanium alloys do have some advantages, but generally not a huge advantage over stainless steel. But where the small difference in performance matters, even if it's sort of a 1% advantage is a huge thing in a Tour de France race. That's where we started seeing titanium be used, and these days carbon fiber reinforced polymers, carbon fiber being more popular in bikes all the time just because of very, very high strength to weight ratio and very high stiffness. The problem is that it's not always easy to get the bidirectional strength. When they fail quite catastrophically. Rubber is obviously used in the tires. They give excellent ride quality, excellent traction, good shock absorption. Polymers are used in the sheathing of cables, excellent durability. When we say durability is probably something you shouldn't write in the HSC as well. I used to write durability, but apparently it's a bit of a no-no. You should instead say it has resistance to UV, it doesn't corrode, it has good wear resistance. That's probably a better way. And good waterproof. All of those things are advantages. Okay. They don't go through with trains, but I can live with that. I don't need to go through the material properties of trains. I'm going to talk a little bit about trains, though, in this other window that I have here. So just a little bit of terminology that I just thought I might use. We can talk about the infrastructure that goes into trains. Obviously, the big part of the infrastructure that goes into trains is the rails. So rails are they sit on rocks. Well, okay, so the rails themselves, so these are the rails. They sit on, what do we call these things that join the rails? Sleepers, exactly the word I would use. In Australia, we call them rail sleepers. In America, they call them rail ties, right? I didn't know when I was reading, there's a book called Atlas Shrugged. It's a very long book about written by a very angry woman, person. She's like a famous right-winger. Anyway, but in her book, it's all about trains, and they talk about rail ties. I'm like, what's a rail tie? Anyway, so I looked up that a rail tie is what Americans call a railway sleeper. Originally, railway sleepers were made out of hardwood, but these days they're more likely to be made out of concrete, just because of the availability of hardwood. Once upon a time, timber was really readily available. It's cheap, grew on trees. Whereas now, we have plowed through the world's store of old growth hardwoods, and these days to grow hardwood would be actually more cost prohibitive. Go.
The fact that timber rots also be
Absolutely. The fact that timber rots is also a huge factor in why we don't use it. Concrete is stronger, more. I don't want to say durable, but it's more resistant to erosion. It doesn't biodegrade. It doesn't get eaten by termites. All of those things. It's not even affected by water. It doesn't swell. Yeah. Oh, yeah, and that's the other thing is that we can mass produce them into exact dimensions. So that's a huge factor. Even their weight is probably a good thing. It helps to keep stability. Okay, so the sleepers, they don't sit on the ground. They sit on a pile of rocks that we call ballast. And the reason for that is we want the water to be able to wash through that ballast. We don't want it to be clogged up with sand. So that way, if there's like flooding, we don't want it to flood and wash away the tracks. We just want the water to just pass through. It also allows us to get the dimensions exactly right. In order to set those rocks so they don't move around, they use a tamping machine, and the tamping machine shakes the rocks so that way they don't vibrate when the train goes over. They're held together. How do they hold the rails to the sleeper? Pin-looking things. Okay, so what they used to use, so there's a whole Wikipedia article on different ways that you can hold things in. What they used to use is spikes. And what's really interesting is that often there would be a golden spike, and the golden spike, there's a company that makes 18xx games called Golden Spike Games. The golden spike would be the spike that there was a last spike that was nailed in to say that this is finished. So it could usually be engraved, and then the mayor would say, in 1869, this railway was completed. I don't know which one, somewhere in Utah. this railway track was completed in 1869. So the gold spike is sort of a ceremonial thing. I don't know why people then don't just go and pull out that spike, but because it'd be worth a fair bit. These days they use clips, right? So rail track clip fastening. So pandroll is the term I would use. Pandroll clips. Here's a giant pandroll clip. And pandroll clips are really interesting because they allow for the thermal expansion of the rails. That was a question I was asked during my chartership interview, and I did not know the answer. Anyway, and then at the end I asked, hey, just out of interest, would you mind telling me how do we account for thermal expansion? And they said, it's not our job to tell you that. And I'm like, okay. Anyway, I mean, I went back and I discussed it with my boss, and we looked it up on the internet and that sort of stuff. But I think the problem is that the world is now so specialized. This is totally off topic, but the world is so specialized. It's very hard for them to, like, when I went for my chartership, they try to get specialists in your field. And so when I said that I was a trackside infrastructure specialist. That's what I did, is that I specialized in digging the trenches that you put the signaling cables in. And what they got was 2 rail specialists. That's a very different field. So the rail people are different to the track people. The rail makes sure that those 2 rails are in the right spot, that they're the right gradient, they're in the right horizontal location. That's their job. And they're really about making sure that when you design that rail alignment, that you're not going through too much rock, you're not having to fill in too many valleys. Whereas trackside infrastructure is really about knowing all the other services that go underneath the trains. So where all the water pipes are, where all the electrical cables are, all of that sort of stuff. Anyway, they passed me in the end. So, I mean, they passed me on that day, so it wasn't a disaster. But I think that's an important thing to say, that rather than me trying to come up with an answer, I just had to stop and say, I don't know. And that was the right answer. I said, I'm sorry, I don't know the answer to that. I'm not a rail specialist. That's just not something that I have spent time thinking about. And that was the better answer. If I tried to make up an answer, that would have been me demonstrating that I was willing to work outside of my area of expertise, which is why you might have heard me in the last year say often, I don't know, that's outside my area of expertise. I try not to bluff when I don't really know the answer. I try to look it up, or I try to ask one of you to look it up. Okay, moving on. Environmental impacts. Obviously, a bicycle takes up a lot less space on the road, right? You can fit a lot more bicycles on the road. Bicycles don't need fossil fuels to run, generally, right? You can have those e-bikes, but generally, even if you do run an e-bike, they're still way more efficient than a car. The downside is, and this is something to write if you want to give a comprehensive evaluation of bicycles, you do have to remember that bicycles take energy to be produced. There are plenty of bicycles in rivers, right? So they're not always fully recycled. So that's a cost that we have to consider. But both of those arguments still are much better than cars, which is the obvious alternative. So in a world where cars exist, bikes are better from an environmental point of view. My brother, and I agree with this, is that these days, if bikes didn't exist and someone said, hey, I've invented this thing and people are going to use the same roads that cars use, people would say, that's way too dangerous. No, we're banning this device. And I do think that there's an argument to be said that roads should either be bikes or cars, not both. Okay, trains also had negative impacts on the environment, right? We saw that a lot of trees were chopped down to make those railway sleepers, right? A lot of coal was dug to fuel those trains. These days, though, we generally consider trains to be very efficient. They're I think, 15 times more efficient per passenger than planes, and that they're like 4 times as efficient as cars, something along those lines. So it depends if it's one person in a car, but you can fit 4 people in a full car, and you can fit 100 people on a train. So if you're comparing apples to apples, trains are really, really efficient, or way more efficient than cars. You get to meet new people. You can be one of those people that says, "G'day, mate, how you doing?" And then start up that conversation. Okay, so steam trains were incredibly inefficient, but these days they're way better. It's important to remember that electricity doesn't come from free. We have to pay for it somewhere. but way better that we have electric trains than it is we have petrol-driven cars or some other equivalent. They're, I think, like I said, 15 times more efficient than aviation. Okay, diesels, we talked about those. We still use diesels for interstate freight because we can't afford to, and it wouldn't be practical to electrify the train out to Broken Hill, for example. Yeah, for passenger and freight, trains are more efficient than road vehicles.
What about batteries on those sorts of trains? The batteries would just be too large?
Great question. So I just was asked, what about batteries for trains? I'm willing to bet there are people who are definitely working on it, but I'll put it to you this way. So a truck, right? So like a B double, right? So what we call like a semi-trailer, that can be like 40 tons, I think is going right. Whereas a train can be 10 times that. For a standard locomotive, that's a pretty reasonable. Tesla is working on a truck that runs on batteries, but you got to think a train is going to need 10 times that sort of storage, just because it's just pulling so much more. But you got to remember that the trains, because they run on smooth rails, right? That there are advantages there. That once they get up to speed, they're very efficient over long distances. But the point is that we're going to have to get to trucks before we get to trains.
The other thing is just adding another carriage onto the train, which is a whole battery, could be like a potential thing.
Exactly. Okay. So the suggestion is, and so this is the argument, right? So in the case of super trucks, right? I think that's what they're called. The super trucks were like the tank, weren't they? In terms of the semis that Tesla is producing, the BWs, they need to think about whatever weight is going into a battery is reducing their payload, what they can carry, right? And that's a real consideration, right? These batteries weigh more than the petrol or the gasoline that we currently put into those trains. On the other hand, for a train, we could have an entire carriage dedicated to batteries. That would be that would be an option. But again, we are losing some payload, but I think it would be more efficient. The big thing is I would be concerned about having a battery that size that's moving around. That's a consideration. So maybe what you would actually do is store each carriage, have its own small battery. So that way you're not having one big battery that could catch on fire or something like that. We're living in the golden age of, maybe not the golden age, we are looking at the space race for batteries right now. Right now, there are lots of people, basically every car company is working on solving the battery problem. And so Tesla uses these cold batteries, whereas there's a Real Engineering or a Wellington video where they talk about this could be the future of batteries, where hot batteries could be what we're looking for, because so molten metal batteries, the advantage there is that it's a lot easier to keep batteries hot than it is to keep batteries cold. And that could be a consideration, but it's complicated fields, and there are a lot of very smart people working on it. Okay, how have these things? What are the environmental implications for the use of these materials? Well, okay, so we just talked about timber sleepers, right? The term denuded forests, right, where entire forests were chopped down to produce the timber for railway sleepers, and in some cases to burn. Right. Steel has been the main material since the Bessemer process in 1856. We have large steelworks in Port Kembla down near Wollongong. It's just a little bit past Wollongong. Newcastle is also another big steel producer. Generally, the steel is not what's important. What is important is these cities tend to build up around where coal is and where limestone is. So proximity to limestone and proximity to coal are probably more important than the proximity to iron ore. We can ship iron ore a lot more easily than we can ship coal. So much so that I have mentioned before that I like a game called Brass. In particular, I like Brass Birmingham. I think it's a huge improvement on regular Brass. And in this game, you have to move cubes. And there's coal cubes, which are black, and there are steel cubes, which are orange. And in this game, the thing that you often find is you have to tell people, you have to say, "Nah, you can't do that, mate." And they're like, "Why not?" And you're like, "Yeah, you can't do that because it's not connected to coal." And you're like, oh, I need to be connected to coal. And if you're not connected to coal, you can't build something that needs coal if you're not connected to a rail network that can deliver the coal. But steel is magic, yeah, because you don't need to. It doesn't need to be connected to the rail network. You can get any steel can be picked up from anywhere on the map because steel can be delivered by horse and cart. Because we think of steel as being really heavy, it's nowhere near as heavy as delivering all the coal. The tons and tons and tons of coal that are needed. Anyway, Brass Birmingham, really good game. Brass Lancashire, the one that's on the iPad, is okay. Okay. I mean, it's good because it's a good way to learn Brass Birmingham. That's the value. Anyway, there were some people on the internet who would argue with that, but they're wrong. Okay, cast iron, similar impact to steel, but not used very much these days. Aluminium is seen much more use. So we talked about in cars, in bikes, it sees a lot more use. I've talked before in other videos about how the story goes that Napoleon III found out about aluminium and said, oh, this is amazing. I'm going to make weapons and armor that are made out of aluminium. And then realized that this was way too expensive. So he took the small amount of aluminium he had, turned it to knives and forks, and only the rich guests got to use aluminium knives and forks. Everyone else had to use gold. Now, that's an apocryphal story. That means it's not really true, but there's no good evidence to support it. But it's a funny story, and I'm going to stick with it.
Didn't the Queen swap all her cutlery out for aluminium cutlery at one point? Or maybe it was before the Queen.
Napoleon III is the person it's linked to. Anyway, polymers. Okay, so polymers saw widespread use. So where I say Bakelite, what year is Bakelite up there? People were using shellac, which is a natural polymer, and they were using celluloid for movies.
1909.
But in 1909, Bakelite started to see its first use. But it wasn't until after World War II that people realized that you could make pretty much any shape, very light, brightly colored, waterproof out of polymers. Right? People started realizing that rather than using rubber, we could use neoprene. We could use alternative synthetic polymers as in place of rubber. We could use perspex instead of glass, and it would give us much bigger weight savings. So these are all things where polymers started to be used after World War II. Okay, I'm going to pause there and start a new recording because we're now up to the next chapter, which is simple machines.